Hello and welcome back. This week we're going to take a look at the last three sections of Chapter 3, and they're going to look mostly at slope. Now, the slope of a line, let's take a line here. The slope is just a characterization of how this line moves. This particular line, if we look at it going from left to right, it is going up. So we could call this a positive slope. If we had a line that was going downhill, right, from left to right, that would be a negative slope. Lines going horizontally would have a slope of 0, and lines vertically will be a whole other mess entirely, and we'll take a look at that later. Slope, which we refer to as m, is really just the change in the y variable in ratio to the change in x. So we see here, right, your slope is how much your y changes from one point to the next, that distance up and down, and the x, the distance it changes from one point to the next horizontally, from left to right. If we want to then calculate the slope, we just find the differences between the y's and x's of 2 points on a line. So my slope then, the formula for that is going to be y2 minus y1 over x2 minus x1, where y2 is just the second y point. If I call this my point 1 and this my point 2, then y2 is the y value of that second point, x2 is the x value of that second point, y1 again y value of first point, x1 x value of the first point. And we just are finding the difference between the two y values over the difference between the two x values. So my slope then, m, is equal to 6 minus a negative 2 all over negative 3 minus a negative 7. 6 minus a negative 2, that's the same as adding 2, so I have 8 over negative 3 minus a negative 7, that's the same as adding 7, so a positive 4, which gives me a slope of 2. This slope of 2 then is telling me that my change in y over change in x, right, for every 2 places that I go in y, I change 1 place for x. This 2 can also be written as a fraction, 2 over 1. Right, so for every 2 places I go in y, I move 1 place in x, and that's describing how this line moves along the graph. If I'm here at negative 7, negative 2, from this point then, if I go 2 in the y direction and 1 in the x direction, that gets me to my next point. If I keep doing this, it gets me to all sorts of points along this line, and eventually gets me to that other point that we used to calculate the slope. So the slope again is just that description of how we move along this graph to find our other points. If I wanted to find the slope of this line, I would do the same thing again, using my formula m equals y2 minus y1 over x2 minus x1. So here again, m is equal to my y2. Again, I need to pick a point 1 and a point 2. It doesn't matter which one is 1 and which one is 2. We'll call this 1 and this 2. So my y2 is 2 minus my y1 of 6. My x2 is 6 minus my x1 of 0. So here I have 2 minus 6 gives me a negative 4, and 6 minus 0 is 6. I reduce this fraction and get a negative 2/3. So this is my slope for this line. Again, what this means is my change in y, I go down 2 in y for every 3 that I move in the positive direction for x. So if I go from this point down 2, I then go to the right 3 to get to the next point. Again, down 2 to the right 3, and I get to my next point. I mentioned earlier that a horizontal line would have a slope of 0, so let's go ahead and verify this. So if I find my slope, my y2, again let's choose points here 1 and 2. So here y2 is 5 minus y1 of 5, my x2 of 2 minus my x1 of negative 4. 5 minus 5 is 0. 2 minus a negative 4 is 6. And 0 over 6 is 0. So here indeed I find that a horizontal line has a slope of 0. Let's take a look at the slope for a vertical line. Let's choose this here, our point 1 and our point 2. The slope for that then would be y2 of negative 5 minus y1 of 3 all over x2 of 6 minus x1 of 6. Negative 5 minus 3 is a negative 8. 6 minus 6 is 0. If I try to reduce this, I'm going to have a hard time, because anytime I try to divide by 0, I get something undefined. So my slope then in this case is undefined. That will be true for all vertical lines. So again, just a quick recap: horizontal lines will have a slope of 0, vertical lines, slope will be undefined. Lines that slant upward then, when you go from left to right, are going to have a positive slope, and then lines that slope downward from left to right will have a negative slope. So again, here this red line has a positive slope, yellow line will have a negative slope. Last week we saw that 2 points made a line. This week we can see that 1 point and a slope can also define a line. If we want to graph a line with this point and this slope, we can do so. We'll first plot that first point, 2, 3, 2 on the x, 3 on the y. And then our slope of 3 tells us, well, 3 over 1. For every 3 we move in y, we move 1 and x. So I go up 3 from that point and to the right 1, always starting at the point that I was given to find my next point. I can then connect these 2 points with a line, and that will give me my line. This then is the line that characterizes this point with this slope. This line then goes on forever in both directions. Just don't forget your arrows. There's an equation that uses a slope and a point. It is called the slope-intercept form. Y equals mx plus b. This form of an equation gives us our general y and x variables, where we would plug in a specific value for our slope, m, and a specific b. This b would be the y value of our y-intercept. So if I have, for example, the equation y equals 2x plus 4, my slope then will be 2, or 2 over 1, and then my y-intercept will be the point 0, 4, where 4 is that y value of the y-intercept. We can prove this by finding the y-intercept by plugging 0 in for x. We have y equals 2 times 0 plus 4. 2 times 0 is 0, 0 plus 4 is 4, so y equals 4 when x equals 0, and that is our y-intercept. We won't have to calculate our y-intercept every time, because we'll know that this value is always going to be the y value of that y-intercept. So if we go to graph this, we'll start with that point that we were given, 4, on the y-axis, and then we'll use our slope, 2, or 2 over 1, to find our next point, up 2 and to the right 1. Connect those points with a line, and we have our graph. Make sure to add our arrows to let us know that it does indeed go on in both directions forever. So this is the graph of y equals 2x plus 4. So if we want to find the equation for this line, we will need to find the slope and the y-intercept. So first off, let's go ahead and find the slope. Again, the slope is our change in y over change in x. So we'll have a point 1 and a point 2. So our y2 is negative 3 minus our y1 of 5. Our x2 of negative 3 minus our x1 of negative 7. Negative 3 minus 5 gives us a negative 8, and negative 3 minus a negative 7 gives us a positive 4, which gives us a slope of negative 2. To find our y-intercept, what we can do is use our slope-intercept form. So we start with our y equals mx plus b. We know our slope is going to be -2, and we can plug in one of the points from the graph since we know that those will be a solution to the equation. This gives us, say, -3 equals a -2 times -3 plus b. So we plugged in the point -3, -3, and our slope of -2. All that's left now is the value of b, and we can calculate this by just solving this equation. We have here -3 is equal to -2 times -3, or 6, plus b. Subtract 6 from both sides, and we find that -9 is equal to b. This tells us then that our equation for this line is y equals a -2x minus 9. Again, only plugging in the m and the b value into our y equals mx plus b. We also see here that this y value of -9 for our y-intercept makes sense since our line crosses the y-axis at the point 0, -9. So this indeed is the equation for this line. Next, let's talk about parallel and perpendicular lines. Two lines are parallel when they have the exact same slope. They do not need and cannot have the same y-intercept. As we see with these two lines, they both have a slope of 1, and their y-intercepts for this higher one here has a y-intercept of 0,7, and this has an intercept of 0,4. Since each of these lines have the same slope, they're going to move in the same way, which means that they will never vary enough to intersect. They will go on forever, always being the same distance apart. Perpendicular lines, on the other hand, their slopes are opposite reciprocals. So for example, this green line here has a slope of -1/2, where this red line has a slope of a +2. Opposite reciprocals mean they have the opposite sign, one's positive, one's negative, and they are reciprocals. So 1/2, the reciprocal of that, or the flip, is 2. If you wanted the perpendicular slope for, say, 3/5, the opposite reciprocal would be a -5/3. If I wanted the opposite reciprocal for a slope of, say, 1/3, the perpendicular slope would be a -3. So again, opposite reciprocal slopes will give you perpendicular lines. Perpendicular again means that they cross at a 90-degree angle. So let's say I want to find the parallel line to this y equals 3x plus 3 that runs through the point 3, 0. Well, I know parallel lines always have the same slope. So here I see my slope of 3, so my new equation must also have a slope of 3, and it must go through the point 3, 0. So I can already fill in a lot of pieces into my y equals mx plus b. I'm going to plug in that point 3, 0 and the slope of 3, and then just solve for my b, and I'll have my new equation. So here I have y is 0 equals 2, 3 times 3 plus b. So I have 0 equals a 9 plus b. Subtract 9 from both sides, and I have -9 equals b. So my equation then is y equals 3x minus 9. If I graph this equation, I will have the parallel line to my red line here. So I need to start here at 0, -9 for that point, and then it goes up by a slope of 3, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, so on and so forth. Okay, continuing on forever in that pattern. This then is the parallel line. Next we'll find the perpendicular line. To find the perpendicular line, we need the opposite reciprocal slope to 3, which would be a -1/3. And again, we're going through that same point 3, 0. So here we're just going to again plug in those values. 0 for y is equal to our negative 1/3 times our value of x, 3, plus b. We then just solve for b and we have our new equation. 0 equals negative 1/3 times 3 gives me a negative 1 plus b. I add 1 to both sides and I have 1 equals b. So my new equation is y equals a negative 1/3 x plus 1. If I graph this, I will then have my perpendicular line. So it starts at 0, 1 and goes down 1 to the right 3. Okay? And it does this in both directions. So if I start here at 0, 1, I can also go up 1 and to the left 3, up 1 and to the left 3. And that will also be along that same line. So we see here, this line then is our perpendicular line to y equals 3x plus 3. And it goes through that specified point. Just like we have the slope-intercept form of an equation to graph that line, there's also a point-slope form of an equation that comes from our formula for slope. However, instead of using y2 and y1, we're going to call our point 2 just some general xy point. So in this case we have y minus y1 over x minus x1. This way the xy point here is more general and we'll just keep it as xy, whereas we can think of x1, y1 as a specific point. What we can do to this formula to get rid of the fraction is multiply both sides by that x minus x1. And what we see is that denominator cancels itself out and we're left with over here m times x minus x1 is equal to y minus y1. This can be rearranged as y minus y1 equals m times x minus x1. This is the point-slope form of an equation. If you have a slope, you can plug it in for m, and if you have one point, you can plug it in for your x1, y1, and that will be an equation for that line. So if we have this line, we can find the equation using that point-slope form. All we have to do is first find our slope. Our slope then is still our y2 minus y1. We'll call this our point 1, our point 2. So we have 5 minus 1 over 5 minus a negative 1. This gives us 4 over 6, which reduces to 2/3. So that is our slope. To find the equation, we just pick one of these points. It doesn't matter which one. We'll go ahead and pick point 1. And we plug it into our point-slope form. Again, that formula was y minus y1 equals m times x minus x1. If we go ahead and plug in those points, we have y minus y1 of 1 is equal to our m, our slope, of 2/3 times x minus our x1, or negative 1, negative 1. Yeah, this then is the point-slope form for our line. Our point-slope form of the equation can also be rewritten to look like our slope-intercept form. Anytime you want to write any equation in the slope-intercept form, all you have to do is get the y variable by itself. So just solve this equation for y. Let's go and first distribute here. We have our y minus 1 is equal to now 2/3 times x, which is 2/3 x. And then here this is minus a negative 1, this is a positive 1. So 2/3 times that positive 1 is plus 2/3. Then again, I'm solving for y, so I need to add 1 to both sides. I'll make sure to line it up with its like term, and I have y equals 2/3 x plus 2/3 plus 1, and 1 is the same as 3 over 3, so that we have that common denominator, giving me 5/3. So this point-slope form, we just solve for y, and we now have it in slope-intercept form. where 2/3 is our slope and 5/3 is our y-intercept. Our 0, 5/3 is our y-intercept. A small swimming pool is being emptied by a pump that removes water at a constant rate. After 1 hour, the pool contains 5,000 gallons, and after 3 hours, it contains 3,000 gallons. Find when the pool will be empty. Now, this is chapter 3, so pretty much any problem you get will have something to do with graphing. So let's go ahead and see if we can't understand this information in terms of a graph. Anytime you're graphing information, your x value is always going to represent time. So then our x-axis represents time. Now it doesn't really make sense to talk about negative time, so when we start emptying the pool, that's going to be time 0, right where we started. And then going on from there will be our hours. So 1 hour, 2 hours, 3 hours, so on and so forth. Our y variable then will represent the other value that we're measuring, in this case gallons, or thousands of gallons. So if we start here at 0 gallons, we have 1,000, 2,000, 3,000, 4,000, 5,000, so on and so forth. So if we have that information, let's go ahead and see if we can't plot these points and see what it tells us. If after 1 hour the pool contains 5,000 gallons, well, here's our 5,000 gallons, and here's after 1 hour. That gives us this point here. Okay, after 1 hour, it had 5,000 gallons. Then, after 3 hours, it contains 3,000 gallons. So we go to 3 hours and 3,000 gallons and put a point there. Now we have 2 points, and 2 points make a line. These 2 points are the point 1, 5,000, and 3, 3,000. We can then calculate the slope between those 2 points. Our slope again is m equals our y2 minus y1. We'll call this our point 2 and this our point 1. So our y2 is our 3,000 and our y1 is our 5,000. Our x2 is 3 hours minus our x1 of 1 hour. 3,000 minus 5,000 is a negative 2,000, and 3 minus 1 is 2. This gives us a slope of negative 1,000. Again, this slope is a rate of change. It tells us the rate of change, or the change in y, our gallons, versus our change in x, our time. So this is telling us that for every 1 hour we go down 1,000 gallons. This then is our slope, our rate of change. So our slope then here is a negative 1,000 gallons per 1 hour, if we wanted to make that a fraction. So this then is how fast the pool is draining. We can then write an equation for this information. We have our points. We can go ahead and pick one. Let's go ahead and say pick point 1. So we have our y, let's say 5,000 gallons, is equal to our slope, negative 1,000, times our hours at that point, 1, plus b, where b again is our y-intercept. If we solve this, we have 5,000 equals negative 1,000 times 1 is just negative 1,000 plus b. We add 1,000 to both sides, and we have 6,000 equals b, which tells us the equation for this information is y equals negative 1,000 x plus 6,000. That means our y-intercept is right here at 6, because 6 here represents 6,000, and then it will go through those 2 points on its way down. Now it looks here like it's going to end at 6 hours to find out when the pool is empty. This here, when our gallons are at 0, that is when the pool is empty. It's also our x-intercept. So if we want to calculate exactly our x-intercept, we need to plug in 0 for y into our equation and solve for x. So I plug in 0 for y, it gives me negative 1000x plus 6000. I'm going to subtract 6000 from both sides of the equation to get my x term by itself. And I have negative 6000 equals negative 1000x. I want to get x by itself, so I divide both sides by a negative 1000, and I get 6 equals x. Again, x represents our time in hours, so indeed our x-intercept is 60, which means there are 0 gallons left in the pool, so it is empty at 6 hours. So we learned a lot about draining this pool just from creating our equation. We saw that it started with 6,000 gallons at time 0. When we started draining the pool, it had 6,000 gallons. From that slope of negative 1,000, we see that it dropped 1,000 gallons every hour, and then eventually was completely empty at our other intercept after 6 hours. And of course that line we created went right through the 2 points that we were given. This equation can also help us find exactly how much was in the pool, say instead after 2 hours or 4 hours. Since we're not initially given that information, we can then find it by plugging in to this equation. If I wanted to know how many gallons were in the pool after 5 hours, I would plug in 5 for my x, since x represents time, and then solve for y to find out how many gallons, since y represents gallons. So this is a little bit of practical usage for our graphing. That will do it for chapter 3. Make sure you go and do the homework and quiz for these sections. Next week we will be reviewing all of chapter 3, and you will have to complete the pre-test and test over chapter 3. Again, as always, if you have any questions, you can ask me in the discussion board, or I am also available through email. I will see you all in Blackboard.